by gathering some of the brightest young minds in the scientific community. SIYSS hopes to inspire by showcasing what it means to be a scientist. However, science is not just about doing research and presenting your findings, it's also about communication across disciplines in order to tackle greater issues in society.
Yes, and Minds of the Future will highlight this by providing this stage to SIYSS participants, representing different countries and disciplines. And the purpose of this panel, of course, this panel discussion, sorry, is to raise awareness of some of society's great issues, but also inspire hope that scientific collaboration can create a better future.
And Morten, you will start to present the 4 selected young scientists that will take part in this conversation.
Exactly, and you clapped so well last time they were on stage. You should do just the same thing once again. So welcome back up on stage. Anna Cochran, Alyssa Göransson, Kevin Chen, and Anna Olivia.
Welcome up on stage. And as you can see, we have 2 seats that no one's sitting in right now. One of them is for the moderator of this conversation, and the other one is for our honorary guest. And I'm pretty sure nobody knows that this person is joining us today. So it's an honor to present to you the Nobel Prize laureate in chemistry 2024 for computational protein design, Professor David Baker. I will take the opportunity to just ask you a question or two before we start. How was it to get that round of applause to begin with? Was it good?
Very nice, very nice. And it's lovely to see all of you.
So first of all, congratulations. You have found a way to create brand new proteins and to create new functions of proteins. And this great opportunity, it's quite hard to grasp what it can mean for society. What are you most excited about with this?
Well, I'm really excited about the possibilities across a very broad range of areas, including things in medicine, making medicines that are more precise and have fewer side effects, better vaccines, to sustainability, trying to make proteins now that will break down plastic and other pollutants, and also whole new types of technologies and materials. There are things in nature like tooth and bone and shells, which are made by proteins interacting with completely inorganic stuff. And I think there's a huge world of possibilities there. So there's a lot of really exciting things.
Imagine finding a way to come up with a protein that doesn't exist. A big round of applause for that. I know Morten also has a question.
Yes, of course. Welcome up on stage. So, in this exciting work of yours, what would you say is the thing that motivates you the most?
Well, I think there are a number of things. It's really exciting to try to make the world a better place. It's really wonderful to work with lots of really brilliant people who are just excited to be discovering new things. So I really like the collaborative aspect of doing science. It's really a human activity, fun to do as a group trying to solve a hard problem. And it's really fun to work on something that could be really impactful.
Wonderful.
And make the world a better place. So
yeah. I can imagine there are a lot of great people in your field to work with.
Yeah.
Wonderful. Thank you so much.
Thank you. Please have a seat.
Another round of applause. Let's do it. Okay.
To help us moderate this discussion.
Exactly. To help us moderate Minds of the Future, this conversation, we present to you the acting CEO of the Nobel Foundation, Anna Sjöström Douagi. A big round of applause.
We leave the stage to you.
No, you can't. Now you can hear me. Thank you so much. It's really an honor to be here. And today we have had the honor to welcome all of you laureates to Stockholm. But to meet all of you before you get to become laureates, it's even more honorable. So it's great to be here. So I take a seat here and I will try to take my notes. So I hope you all had a very good and challenging day. I know that it has been a day full of presentations and poster sessions. Wish I would have been here to take part of all these wonderful breakthroughs that you all have presented. So it's really an honor for me to be here with you today. I'm the host for this discussion, and as you heard, with me we have a beautiful panel and the Nobel Prize laureate in chemistry this year, Professor David Baker. And it's the third time for me to host this session, and each year I'm both humbled and inspired by both the ideas and questions that are emerging from these discussions. And I have no doubt that this year will be any different. Young people are crucial for developing new solutions to secure our collective future. A future where challenges no longer concern singular nations, but have reached a global scale and requiring global solutions. With that said, it's my pleasure to introduce the first topic for today's Minds of the Future, the role of STEM in addressing global challenges. STEM research plays a significant role in tackling global challenges such as health and environmental sustainability, and its impact can positively feed back into communities. There are endless examples of scientific research having positive effects on society. Advancement in renewable energy technology have reduced electricity generation costs by 160 billion euros. And biomedical science has enabled the development of treatment for previously life-threatening diseases. And just as recently as some years ago, David Baker's work on protein structure prediction provided the foundation for developing a COVID-19 vaccine. Transformative scientific innovations can, however, have unintended effects. And for example, renewable hydropower can impact aquatic biodiversity. This challenge illustrates the need for responsible scientific applications involving both researchers and policymakers in the decision-making process. So the possibilities for STEM research are really immense. But how do we make sure the outcome of research feed back into communities? And how can we make sure that they have a positive impact on tackling global challenges? So, Anna, maybe you would like to start with some comments on this?
Yeah, sure. So I guess there's kind of multiple angles you can look at it from. So in terms of thinking about potential negative and positive impacts of new research, I think it's mainly just important to keep kind of a balanced perspective on things. So while like every scientist is really keen on looking at only their area, it's important to kind of have knowledge of what else is out there and think about other sides of the argument. Obviously, influencing policymakers is super important. As individuals, we only have so much power to make change. So I think if change can be made through policy, that would be really good. And kind of from the other side, maybe scientists speaking to the media a bit more. I know that scientists don't always like to, because sometimes it can kind of get maybe twisted or not represented quite as we'd like with the same complexities. But I think even so, information is so much more powerful than misinformation. And if the public believes in the research we're doing, then that will help policy along as well.
So scientists should speak both to policymakers and to media and to try to be a link with the society. Yeah, I guess that's very important. So David, can I ask you, what role do you think that scientists and engineers could play in ensuring that the research they do have a positive impact on the society?
Yeah, well, I would agree that being active in communicating the science to the world, to policymakers, is important, and really to engage the groups that are, that are relevant. Also, I think making an effort to take the science that's being done and really get it out in the world. And there are a lot of ways that can happen now. So for example, from my group, many people go on to start companies or join sort of policy think tanks which are really concerned about getting things out in the world and working out the issues that are involved with them. So I would say staying engaged at all levels is very important.
So you tend to agree, both of you?
Yeah.
Yeah. Anna, I wanted to ask you, how do you look at your role as a young researcher in advocating for science on a global scale?
I think as a young person, it's obviously I have much more energy perhaps than an older professor who is a bit worn. So like I can go around and travel and talk about science without feeling too horribly jet lagged. But I think more importantly, I have this time now in my career to go and connect with other young people. So because I'm a more similar age range to you guys, I know a bit more how youth culture works, and I know a bit more about strategies to really spread science in a more democratic way, rather than just remaining in an academic context.
So actually also being a young researcher has advantages because you can also speak with young people in another way and maybe relate a little bit different. Yeah. So I think, there are many levels now of interaction, but also important things that needs to be prioritized.
Yeah, I think I agree with that completely. The other thing I just wanted to add was, as young people, maybe when we talk to the public, when we talk to people of our age, we can use more lay terms. We can try to communicate in a way that everyone understands. And as we previously said, whether it be pandemic or other sort of scientific communication, to prevent misinformation, there needs to be more communications occurring, but not in a form where we talk about our research directly, all about numbers and data that nobody understands, but in a way that everyone sort of gets engaged and understand what we're talking about. So that kind of mutual communication not only helps us build our case, but also helps people understand where we're coming from. And there's so many platforms nowadays, whether it be YouTube or short videos online, there's so many ways of communicating science to young people. And I think for us, we have so many different opportunities to talk to the public in a brand new way, more engaging way.
Just looking today here for you who are here and listening to this panel, I think it's wonderful that both that the room is so full and that the interest for this is so full. And I hope that many of you here today will bring this discussion with you and go home and hopefully want to pursue a career in science, because that's really a fantastic opportunity that can lead to so many different things. So I really hope that some of you at least get a really big spark of interest today. So Anna, I wanted to come back to you and ask you, how do you think STEM research can help tackle global issues like climate change or health disparity or poverty for that matter?
Yeah, I guess science kind of helps on multiple levels. Like, first of all, just identifying these problems is quite a big thing. So I guess the nice thing about science is it's quite empirical. Like, you look at the evidence and then deduce things from that. So you're looking quite unbiasedly at the world and therefore can identify issues which we might not otherwise. And then you can therefore also identify the solutions to them, hopefully, and then test it. So looking at case studies, running clinical trials, all that kind of stuff, to really inform policy on what works and what are the important issues we need to focus on.
Thank you. And I wanted to come back to you, David. You are a chemist and you work with predicting how proteins can look like. But how do you see your research relating to those global challenges, and how do you think your work can help?
Well, I think in really two ways. The first way is that we're designing proteins to deal with, in part, to deal with diseases of the developing world. And so I think, and one of the ideas is that the sorts of medicines that we're generating based on designed proteins don't require a cold chain. They're easier to manufacture, and so they could be ultimately lead to more equitable health solutions. As far as I think I mentioned already, as dealing with issues like plastic degradation. This is also a problem that really affects developing countries. So I think in part by developing new design protein-based technologies to deal with some of these issues. But I think the other way is really in, you know, I have a large research group with people who come from all over the world, and you know, the people that come through all sort of have a vision of doing, you know, of trying to make the world a better place and really having an impact. And then they go out all over and then you know, in sort of the way that we've been describing, you know, they're able to communicate the issues and really go to a lot of different places. And so I'd say it's both through the science and the actual specific solutions to problems. That's the first thing. And the second is just through all the amazing human talent that's coming through and then going out in the world.
Thank you. I think it's interesting also because maybe many of you think that going into a career in chemistry is a lonely work where you sit and you do your experiments, but you hear it's international collaboration. You can go out and tackle global challenges both within health and climate. So I think that's a very important message.
Yeah.
Alyssa, can I come back to you and ask you, how do you think STEM research can help politicians and people in power to make decisions in those pressing global issues?
Yeah, I think that to be able to make these kinds of decisions, you need kind of to see that it works and that it's a good thing. And that's basically where the STEM research comes in, to try to develop these new technologies and such to kind of prove what could work and not. And then the policymakers and politicians could kind of take a stance to that to be sure that their decisions are sustainable and a good choice for the future.
Thank you. It's sometimes difficult for policymakers to understand maybe how science can change, but even if you change a little bit, it doesn't change the whole picture. But so of course there needs to be scientists like you who can talk to the policymakers.
Yeah, of course. And if you, for example, have interdisciplinary research, you can communicate your research to someone in between you and the policymakers to make sure that it's communicated effectively to the policymakers as well.
Thank you. Kevin, how can we help policymakers to take scientific research and data into account when they take the decisions?
Yeah, I think that's a great question, especially during COVID. We saw a lot of communication that, I think, I'm going back to that point. Communication is the key. Not only do scientists need to talk to the public about what's been happening, they also need to constantly talk to policymakers and ensure that the policy that we make are evidence-based and are based on data and not just what's best short-term, what's best, what makes them look the best. And I think as scientists, we have sort of two main responsibilities that I can think of. One is to make sure that we communicate and then the policies made are evidence-based. And the other is when the policies that are made are not evidence-based and they sort of derail from what data and experiments have told us, we need to come out and say what we've discovered, what the discrepancies are, and why we maybe disagree with that. So we're more transparent with the public about what we've been studying and what the policy should be, what we think the policy should be. So again, there should be a three-way communication that includes everyone in the picture to make sure that the policies are evidence-based and that the public understand why the policies are the way they are.
Thank you. And coming back to you, David, Kevin mentioned COVID-19, where we saw science happening in front of our eyes, and it was difficult for many people to understand. One day it was one thing, and one day it was the other thing. And your work was actually also very important in the vaccine development. But do you have any suggestions or thoughts on this, on how to make policymakers or the society more understand the scientific results?
Yeah, I think better communication is important. I think one of the big challenges in the world today is sort of the fragmentation of the media, and you all know all about that. You can anything that you want to hear, you can find, and so I think having just more informed people overall. That doesn't necessarily translate to more informed politicians. I mean, we have an interesting situation. We're coming up to in the United States now. Yeah, but the thing that makes me somewhat optimistic, though, is that in the COVID pandemic in the United States, there was a lot of crazy misinformation that was going around, and yet the same administration, which was sort of perpetuating some of that, also made a huge investment in vaccines, which turned out to be really, really important. So I think it's important to be well informed, but also not to give up on people that don't necessarily agree with you. And I think just more engagement across the board is good, because people can come to make the right decisions even if they initially have thoughts or opinions which are maybe not absolutely correct.
Very important. Thank you. I'm just looking if do you want to? Yeah. Do you want
Oh, sure. Coming from the US, where Dr. Baker is from, I can say definitely I've seen a lot of the processes that he's mentioned occurring in the country. But I think also another angle that we could take with this aspect is putting more pressure on the policymakers to be informed about science, because we as scientists can tell them, look, it's better if you do this, it's better if you do this, but without having somewhat of a foundation in a basic understanding of the science behind the policies they're putting into place, I think it's a lot harder for them to actually take the advice into account. So I think perhaps in the electoral process, when you're considering who to vote, what to vote for, also one of the biggest questions you need to be asking is not only which problems are you going to solve, but also, do you understand the science behind the problems? And I'm not saying that policymakers need to have an extensive background in science. I'm just saying that it would be better if we put more pressure on them to understand at least the fundamentals behind the biggest scientific issues.
Thank you. Just looking if someone wants to add something to this. What I hear from all of you is communication, communication, communication. And that is on different levels and with different actors. Talk to media, talk to policymakers, talk to people that might disagree with you, and also the very big need for education and to have an informed both society but also informed policymakers. So I think what you are doing out there in school, it's so important that you are part of this increased informed society that can both understand the work that comes from science, but also can help informing others, your friends, family, and other policymakers about the need for science and how to interpret the scientific results. So that is what I bring with me from this topic. Thank you so much. Now we have come to the second topic of today's Minds of the Future, and it has been highlighted by Luleå University of Technology. And it's fostering curiosity in science and increasing the presence of science in society. STEM research is important for tackling global challenges. To ensure continued scientific advancement, it's vital that we foster curiosity and increase the presence of science in society. The Swedish Royal Academy of Engineering Sciences, EVA, they published a report examining how young people aged 10 to 15 viewed STEM. It showed that while most of the students picture science as important, only 5% are interested in working on environment and climate change issues. Another report from Teknikföretagen cites that 1 out of 3 students have been advised not to pursue a STEM career in high school, many times by their own parents, teachers, or study advisors, despite a labor market screaming for this competence. It reports a fear of STEM being too challenging as the main reason for the discouragement. The EVA study showed that many students lose interest in STEM as they progress through middle school, but at the same time, there are others who manage to maintain or even deepen their passion for science, such as the panelists here today. And we would like to hear your insights and thoughts on what inspired you to explore a STEM career. Your experience and perspectives can shed a light on what can ignite an interest, and perhaps why it sometimes fades for others. We really want you to keep the spark going. So why did you choose STEM, and why are you here today? Do you have any early memories of science that made an impact on you? So I start with you, Kevin.
Oh.
Yes.
I actually had a very strange high school experience with, well, in high school I was horrible at biology. I did not want anything to do with genetics. When we're talking about mitosis, meiosis, I couldn't figure out the 4n, the 2n, how many copies of chromosomes we're talking about. So I actually started really late. I thought in high school I wanted to do computer science in university, and I went in thinking I was going to do computer science or maybe medicine. But then in first year of university, there was like a fresh restart where I was interested in biology, but I was more like, should I try it? I'll go try it. It looks quite interesting, and it's necessary for med school, so I was forced to do it a little bit. But it was I find very grateful that I was sort of forced to do it, because I find my love with biology, especially with genetics. And so in second year, I majored in genetics and kept doing genetic-related subjects, and then started doing research about it and really fell in love with what I'm doing now. So I guess the moral of the story is, as high school, you may not know what you wanted to do. You may not know if you're interested in STEM or not. But the more important thing is, if you're interested in general, like problem solving, if you have a problem that you can't understand, the joy of finding your own solution, and keep that spark of interest going. And at university, try out different things. You never know what you'll fall in love with. And it's really important, if you're doing STEM, to be passionate about what you're doing. And if you're really interested in it, you'll do really good because you love what you're doing. So that's really important.
That's that's what we hear from many Nobel laureates, that you have to find something that you really think it's fun, because it's hard work, and you need to think it's fun, and you have to feel the passion to pursue and maybe persist on those days that are a little bit heavy. Alisa, did you want to bring, or did I miss?
Yeah, of course. I can share a bit of my story, I guess. So I grew up with my dad, and because he was a single parent, I used to follow him to work quite a lot. And he worked in industry, and he usually went around to houses as well and to install heat pumps. So I got to follow him and watch him work. And so I always have seen the technology, and I was kind of interested in learning how it worked. And then when I got to choose partly gymnasiet, but also university later, I like the problem solving of math and physics, and that's why I wanted to go into engineering. I didn't go into energy engineering with the goal of saving the world, but I thought that maybe if I get this education, maybe I can contribute a little bit with what I can do. And I'm very happy that my research might be able to contribute a little bit at least.
Thank you. Now I'm looking to you, David, because I just brought up how other laureates often talk about their work.
Yeah.
So please.
Yeah, I would like to echo what was just said. And actually, when I went to the university, I didn't plan to study science at all. So I was actually social studies, and then I was interested in philosophy. And I did take a chemistry class along the way, but I think it was the worst course I took in all of university. I mean, in terms of how well I did. I remember that I would come home, the way we had these labs, and you have to mix things together, and I would spill half of it on myself, and come home, and my roommates would make me put all my clothes outside the door. And it didn't really mean anything to me. It was just mixing things together. And then later, actually in my last year at the university, I took a biology class and got very excited about what was being learned. And I think it was really that feeling that new things were being discovered. And what for me has been, what I really love about science is it's really the activity, like discovering new things, particularly working with other people to solve hard problems. The facts, once they're established, are a little bit less interesting to me, and that's why, in high school I just wasn't interested, and early in college I wasn't interested. So I think, like was said earlier, I think the most important thing is just follow what you're really excited about and what you're really passionate about. It might be science, it might be something else, because whatever it is, if you're really excited about it, you'll do something, you'll put your energy into it, and that will lead to something. And you can't really plan too far ahead. I mean, I hated chemistry in high school, and I had no interest in chemistry in college, and here I am with a Nobel Prize in chemistry. So you just can't predict what's going to happen. So just do what you're excited about at any given time, and it will lead you to a good place. You just have to keep updating, though, because your interests will likely change over time.
Thank you. I think that can be a little bit comforting. I mean, even if you maybe today doesn't have the passion in chemistry, actually, that's not the last word said about that, because you might end up here.
You might be sitting here someday.
Exactly, and we will talk about your memory from that day when you listened to David Baker and you realized that chemistry was maybe something for me. Anna, I wanted to ask you, which strategies do you think are most effective in increasing awareness of and interest just in basic research and science?
So I come from a background more in math, and I hope to do physics and math when I'm older. And so I can really speak to the basic aspect. And I think it's just an understanding of why you're doing what you're doing. A lot of times in schools, there's an emphasis on competence in the subject, which is helpful later on, but it's not really inspiring love for the subject. So I fell in love with science not because of something I learned, but because of a documentary of the Large Hadron Collider experiments at CERN, where I saw the scientists collaborating and discovering something new, and the unanswered questions that were open for anyone to answer. And so it's this idea that I approach science very casually, not from an academic environment, but from oh wow, this is really interesting, I'd like to know this. So perhaps it might be better then to also expose children, and then also people our age, to a different, more artistic interpretation of science, where you know the reason behind why you're learning this chemistry, or the potential applications to help the world. And I think by doing this, we could improve engagement in science.
Thank you. Thank you so much. Do you want to add?
I just wanted to add, going back to way before, doing science is definitely not what the stereotypes like. You sit on a lab bench all day, do your own experiments. There's a lot of meetings. There's a lot of discussion between you and your colleagues. You're always trying to understand new discoveries, new findings through your experiments. And what's exciting is if you're trying to do something groundbreaking, when you do experiments, you don't know what to expect. You're going in every day, you're looking at the results, you're now trying to understand how to interpret it, so it's very exciting. It's not doing repetitive pipetting all day. You definitely have a purpose when you're doing experiments in the lab.
Thank you for adding that. I think that's really important to understand about the work of being a scientist. So Anna, I wanted to ask you both maybe to share your story, how you came into science and why you have this interest, but also if you have something especially you would like to say to the audience if they have any doubts of going into a career in science.
Yeah, I mean, I guess I kind of also fell into science kind of indirectly. Like, it wasn't like I was super passionate when I was a child. I really liked problem solving, and I liked the logical nature of it, and kind of just enjoyed it more and more, and really started getting passionate, I guess, same as David, like at the point of seeing the actual cutting edge research happening, like the idea that we were actually able to discover new things rather than just being taught. I guess in terms of people having doubts, it's always a good option to take in terms of like it leaves a lot of doors open. But also just it's a lot of fun. Like science is one of the only careers I know where like most researchers I know get excited about their work nearly every single day, which is really not to be said for most careers. So I think that shouldn't be undervalued.
Thank you. And David, you talked already about your younger version of yourself, but if you were sitting in the audience today and you were, say, 18 and you were not so much fond of chemistry, what would you have said to yourself out there?
What would I have said to myself?
Yeah.
I would have said, it's fine you're not interested in chemistry. It's maybe, just do what are you excited about? What are you really interested in? And actually, when I was 18, I had no idea. When I went to the university, all of my friends knew exactly what they wanted to do, and they were very excited about it. And to me, it was like, you know, everyone else knows what they want to do. How come I don't know what I want to do? So I really didn't know. I kept trying different things, and so I guess that's something. If you really don't know what you're interested in, keep experimenting and trying new things. I just wanted to add something to say, what was earlier said is, yeah, the image I had of what it would be like to do science was really not right at that time. So now I have a pretty large research group, and the most important thing I tell everyone is you have to be talking to other people all the time. You have to be collaborating. You should not try and solve problems completely on your own, because it's just more minds thinking about things is better. We have different exotic free food events every day to try and get people together to talk, and there's a lot of what I do is try and figure out different ways to get different groups of people in my lab together to talk about how to solve problems. So I'm kind of an expert in sort of how to get groups to solve hard problems, and making the work atmosphere fun and really collaborative is the best way that I found to do that. So just echoing what was said earlier, science is not kind of you're off trying to do something totally on your own. It's really a group activity, and solving hard problems with other people who are your friends and colleagues is really a lot of fun.
It sounds like a lot of fun.
Yeah.
Can I join your lab?
Yeah.
No, but I think what I hear from all of you, and that I think it's also very important for you to bring with you, that maybe that spark of interest, that it can be ignited anytime, and it really doesn't need to be there in high school or even in university, but to find that both playfulness and happiness and joy for this very creative and collaborative work that is much more interactive and international than maybe like the picture that is often put forward of a lonely genius like Einstein, a little bit social, misbehaving almost. That it's really, you need to be very social, you need to collaborate, you have a lot of fun while doing it, and it also opens a lot of possibilities. I think in Sweden, for people pursuing a PhD education, quite a few % is actually staying in academic research. You can go into so many different places. You can become like a acting CEO of the Nobel Foundation. I had a very nice research training in immunology at the Karolinska Institute, which was one of the best years of my life. Fantastic. But I also now have the best years of my life. You can become an entrepreneur because it's almost the same skill set that you train. You have to have courage, you have to have passion, you have to have the courage to question authorities and maybe go in paths that you thought you knew the answer, but you have to go somewhere else. So that's very much like being an entrepreneur as well. You can become working in governmental agencies where that competence is so much needed as well. So it's a very, very broad education that can lead you to so many different things. So I think that is also something that is important, that, as you heard in our previous discussion, we need more informed people in general in society that will lift the whole society. So you are needed everywhere. And if you pursue a research education, you can use it in so many ways. I'm just looking around my fellow panelists to see if someone wants to add something to this discussion, or if there is a message. Yes, Anna.
Yeah, I would also just say that even if you don't want to do a career in STEM, like, you don't need to not think about science at all. Like, there's so many great ways to access science in a casual way. Like, I guess you were saying before, Kevin, about watching YouTube shorts or listening to a podcast or watching a documentary. Like, I think everyone has some interest in science, and it's just like, find what you like and educate yourself a little bit, even if it's not what you mainly want to do.
Thank you. Yeah.
I can say one more thing. And also, even for this week, you know, the work that is being recognized by this prize, of course, I really didn't do any of it by myself. It was done with all my colleagues over the years. And so this week, 130 former postdocs and graduate students in my group and some current group members are coming, and we're just having this huge celebration. And so, yeah, I just want to really emphasize that doing science is a really fun and communal activity at its best. So, yeah, so that's the special thing for me to come here and not only have my family, but have all of my many of my colleagues from from all throughout my the time working on this problem.
Thank you also for pointing that out. I think when you look at the Nobel Prize, that you see that the individuals that are awarded, but actually it's often very big groups of collaborators and colleagues that are part of this big work. And that is, of course, very important to recognize that this is really a group activity. So thank you so much for this. I hope you got a lot of advice and things to think about to bring home with you. So now we have come to the third topic of today's Mind of the Future, and it's the importance of diversity in STEM. Alongside the vital role of STEM in generating solutions for multifaceted issues like climate change, poverty, and health inequalities, there is an urgent need for inclusivity and allowing diverse and interdisciplinary perspectives to contribute to scientific and technological advancements. Some barriers include limited access to the highest quality of education for underrepresented groups. Others concern structural challenges such as pay disparities and unequal promotion paths. Unconscious biases can also affect recruitment and may prevent also how qualified individuals from reaching their full potential. This disparity in representation and opportunity within STEM highlights the need for a multifaceted approach to address global challenges. Meanwhile, the demand for STEM talent is surging worldwide. The number of job advertisements targeting STEM graduates has increased threefold in Sweden over the past 10 years. And from 2011 to 2021, the number of STEM workers with a bachelor's degree or higher has increased by almost 6 million in the US. In the EU, 7 million new STEM job openings were forecasted between 2015 and 2025. Even if a modest increase in diversity within STEM can be observed in the EU, the sector still faces an immense challenge when it comes to broadening its talent pool. And with this in mind, as the demand for STEM graduates is increasing, how can we promote more inclusive and diverse environments in science? What do you say, David?
Well, I think diversity and inclusivity is super important. It's important in really two ways. One way is for a research group, the more I've just found that the more diverse it is, and the more different types of people and viewpoints, the richer it is, and the more powerful it is. And I've seen that very clearly as we've really increased our efforts to have a more diverse, diverse group members. It's really the complexity of the problems we can tackle keeps growing. And then the second part is that, for me, a lot of the the people that come through the group then go on and go out in the world and do all sorts of things. So if people come from more diverse backgrounds, then they'll be sort of poised to address a wider range of problems when they come out. So I think it's super important. It can be challenging. One of the things that we're trying to be very active about that because, and actually it might get worse with the Nobel Prize because even in terms of gender, there's it's pretty clear that some of there's some people who just don't write to me about doing a postdoc, for example, because because they think it's too high powered or something. But in fact, they're totally qualified. So I and a number of people in my group feel very strongly about trying to encourage and really find the most talented people out there who are interested in the area. And it's a challenge because there's a lot of self-selection that people do for the wrong reasons. And so I guess that's one message to all of you. Don't count yourself out for anything because you think you might not be good enough or whatever, because often people's perceptions of their own abilities are not really accurate overall. So But that is a real challenge, and I think it takes it's going to be different in different cases how to address it. But in our case, for example, we look at sort of the kinds of, what graduate students around the world, what kind of, if they're publishing exciting papers, then we try and get them to come in and talk to, give seminars and things. So I think it's a big issue and challenge. But I've also found, and sorry to go on too long, but even in terms of ethnic diversity, that it was much harder at the beginning to get a more ethnically diverse group. But then once I was able to do that, it was much easier to continue to attract people from, different ethnicities and backgrounds. So, and then it's just really fun because, in the lab, you go in the lab, there's people from everywhere who look all. Yeah, it's just fun to be in a more diverse environment.
Thank you. Alyssa, do you want to add something on this topic?
Yeah, I agree a lot with what David said. Like in my division, we're 25 PhD students, and we are 4 from Sweden. So we are there are a lot of people from different countries, and I think it's very good because especially when you look at global issues, you need to have global perspective as well. Because in Sweden we have quite good resources for clean energies, and we have water and so on. And in other countries, maybe that's an issue to even get that. So it's very good for us to actually get the perspective of other countries when we are considering stuff for our research. So I think that diversity is only a good thing, especially when it comes to research.
Thank you. Anna, why is diversity important with STEM and research, and how do you think that can drive creativity and development?
Yeah, I agree with what's been said before. I mean, diversity is important just to have as many different backgrounds available as possible to tackle problems from different directions and just to have different insights, I guess, maybe in specific circumstances, like you say, having people from different countries, or for example, I look at kind of pregnancy intervention research, and actually having people from different cultural backgrounds is quite important to understand what is actually practicable in terms of what interventions we should actually be looking at that are relevant to different cultures. Yeah.
So it's really different, or important with these different perspectives.
Yeah.
I remember we had a Christmas party in my institutions, and we counted nationalities, and we had 70 countries in our house, and it was really very good food coming from that. Anna, I want to go to you and ask, if you can give an example from your own career when working with people from different backgrounds, and that can be ethnicities, socioeconomic, religious, gender, or anything, if that was helpful in a scientific setting, and did your different experiences lead to different opinions, for example, and how do you think that contributes to the scientific progress?
Of course. Well, just today I was actually talking to Alyssa about her project because she's working on finding more sustainable ways for Sweden to use their energy, and obviously the US hasn't focused on that very much, so I loved getting some ideas from her and perhaps taking them back home and trying to implement them because Texas is very big on oil, so... But then also, this past summer, I was fortunate enough to work in a biochemistry lab, and I actually worked in molecular modeling. I worked on developing a new inhibitor for a fungal crop pathogen, kind of piggybacking off of Dr. Baker's research. And I found that there were a huge assortment of people of different nationalities, different genders, and each person brought their own individual perspective. And I think by getting more perspectives, we're more likely to come across a specific solution to a problem. So I came from a background in mathematics, so of course I looked at every assay design very mathematically. What are the numbers? What are the quantities? What do we need to be doing here to get the number that I want, like the p-value that I want? Whereas working with someone who came from background in life sciences, she focused more on different aspects of the experimental design, like perhaps changing certain chemicals to get better results. So just really considering the problem from every possible angle using these different perspectives rather than just my own limited background.
Thank you. Sure. Kevin, I wanted to ask you, and that diversity can have that can also mean interdisciplinary efforts, like bringing together people of different educational and professional backgrounds. Do you have any personal experience of collaborating across disciplines, and how do you think that affects your work?
Yeah, definitely. We're very lucky. Where our institution is, it's a cancer research center, and across the street, it's a research center that does viral research. And then also, it's the University of Melbourne's own department of research across the road as well. And then we also have the Women's and Children's Hospital right next to us, and as well as the Royal Melbourne Hospital right next to us. So we have all the resources sort of available. And what from earlier, what I've talked about, my project about CRISPR-Cas13, there's so much potential opportunities for therapeutics, whether it be cancer, which we collaborate with other cancer scientists in our building, but also in viral works, and we collaborate with people across the road. But then also when we generate thousands of experimental data, we try to make sense of it, then we talk to the bioinformaticians who come up with clever ways of interpreting our data. But we also try to do all these new deep learning with AI to try and help us predict future designs of these models. And so there's so many ways of bringing people from all sorts of backgrounds together, and it's so good to be right in the center of everything, to be able to collaborate with everyone. And the other, I think it's my personal sort of, I noticed that, like, compared to paper 20, 30 years ago, maybe you'll see a Nature paper with just 1 or 2 authors. Nowadays, most papers with huge impact factors will have a lot of people from different schools of studies and have different backgrounds. They all contribute to a single project because, again, this biology is linked to everything, and physics, chemistry. It's so important to communicate with everyone, because for one scientist from one background, they're not going to know everything. They're not going to be the experts in everything. So it's really important to have this diversity in backgrounds, have people from different fields contributing to the same thing. And that's where I think the greatest ideas and new inspirations come from.
Thank you. And we see so many things in the future coming that you need this talking between the disciplines. So it's very important. Alyssa, I wanted to ask you, does your home country or institution support initiatives that encourage interdisciplinary collaboration?
Yeah, like I'm Swedish, so it's your country as well. But my PhD project is actually a part of something called the Graduate School in Energy Systems, which focus on interdisciplinary research to tackle the global like sustainability goals, specifically the climate change. So like in my PhD project, we are 3 PhD students. It's me, I'm like from engineering, and there's one from economics, and there's one that's looking at like socioeconomics. So my project is actually funded by the Swedish Energy Agency. So this is like a governmental investment in interdisciplinary research.
Oh, that's so actually funding can also be a tool of putting together different disciplines. Yeah. That's interesting.
Yeah, like funding is everything in research.
Yes. But David, I wanted also to end by asking you, in your work then in chemistry, I guess when you work a lot with computational design and other disciplines that is needed for your work to be performed. But do you see this need of interdisciplinarity in your own research group?
Oh yeah, so in my group I have computer science, so I have graduate students in computer science, I have graduate students in biology, graduate students in engineering, graduate students in chemistry. So really pretty much every field of STEM, there are students getting their PhDs in that field who are in my research group for their PhD, because to really come up with creative solutions and then to do impactful work, you need to develop new algorithms, which is what the computer scientists are excited about. You need to identify really pressing problems in, say, medicine or sustainability, so you need people from those backgrounds. And what ends up happening in my group is things all get mixed up. So the computer scientists end up learning biology, they have to, and the people who came in not really knowing anything about computation end up becoming pretty proficient computational designers. So yeah, so my area is really incredibly interdisciplinary. I think, and every time we go into a new area, it brings in a new discipline. So that's one of the fun things about my job is I keep having to learn new things. I mean, 5 years ago, we were not doing any deep learning, and now we're probably one of the biggest academic groups developing new deep learning methods. So again, it's like, you know, science is constantly changing and evolving, and I think increasingly, you know, like Kevin said, like to really solve hard problems, you need a really broad range of approaches.
And I think that is also very inspiring that even you as a Nobel laureate, you're not in the, reaching the goal, but you have to be a lifelong learner to be.
Oh yeah, yeah.
To be.
Yeah, I'm really excited about the next 10 years, and I'm going to have to learn a lot of new stuff.
So we are all in the school bench together.
That's right.
Yeah. So what I hear from all of you in this discussion is that diversity is crucial and essential, and whether that may be gender or it is geographical or disciplinary, that when you attack a scientific problem, you need to attack it from as many angles as possible in order to get the question or the answer to come out as accurate and as close to the world as we can. So thank you so much for all these insightful comments. Listening to your thoughts and ideas have been enlightening. Your passion for science is evident and inspiring. And I want to thank you for the work you are doing in building our better, brighter future and giving us hope. And thank you especially to you, Professor David Baker, for being with us here today. I hope that you in the audience, whether in the theater or joining us online, feel both inspired and engaged to create your own contribution to a brighter future. And I encourage you not to let this important discussion end here. Please bring this conversation into your classrooms, science clubs, friends and family dinners. And if you don't know where to start, there are resources available on a website. Only together we will be able to tackle the global challenges. And I also hope to see many of you following the full program for the Nobel Prize laureates this week, and also to follow when David will get his Nobel Prize on Tuesday in the concert hall just across of this marketplace here. And I hope to see many of you following there, and I hope to see many of you in the future and be able to welcome you to us at the Nobel Foundation. Thank you so much for this.